Greetings to you all. We have a very interesting conversation today, where we want to actually consider how to find a determinant. Okay, how to find a determinant of a matrix. Okay, how do you find a determinant of a matrix? So here is the outline of this conversation. So to start with, I will explain some key concepts that guide matrices, and I'll show you how to calculate for the determinants of the given matrices. After we have learned how to find the determinant of a given matrix, then we will also have to look at the inverse of a given matrix. So we'll learn how to invert what matrices. Once we learn how to find the inverse of a matrix, we will learn how we will then pick a question from the Examination Council of Zambia, ECZ. This is 2022 paper, and the practice and exam question. And this is how we are just going to do it. Okay. So now, to start with, a matrix is always defined by a number that has got entries, and these entries are usually named as the rows and the columns. So these lines that go this side, you call them the rows, and these lines coming down, they are called the columns. So when you are defining a matrix, you will have a matrix. Let me give you an example of this one. Let's call this as A, and let's call this as matrix B is equal to the entries A, B, okay, C and D. So now, when we are counting this matrix, we want to state the order of this matrix or the name of the matrix. So we can easily say that this matrix has got how many rows? How many rows does this matrix have? It has got 2 rows, 1 and 2, okay? So we always start by stating the number of the rows, okay? You always have to state the number of the rows. So there are 2 rows, okay? Then again, you think of the columns, okay? Let's think about the columns. How many columns are here, okay? So when you observe critically, you will realize that there are 2 columns as well. So this matrix is a 2 by 2 matrix. That's how it is called. The order of this matrix is a 2 by 2 matrix. What if I put another matrix here? I call it matrix C, and I just put the entries A and B, of which these represent some numbers. It can be numbers, of course. We count how many rows are here. There are 1, 2 rows. So it's a 2 by how many columns? It's only 1. So 2 by 1 what? 2 by 1 matrix. Okay. 2 by 1 matrix. So basically that is what happens. So now you have this 2 by 1 matrix. You have a 2 by 2 matrix. What if you have a matrix like, let's call it matrix B, that has got this order? Let it be AB. Count how many rows. You find there is only 1 row going to the right? So it's 1 by, how many columns are these? We have 1 and the 2 columns. So it's a 1 by 2. So basically that's how you define a matrix. So these can be numbers, okay? These can actually be numbers. So now, how do you define find the determinant of a 2 by 2 matrix? This is what we are interested in knowing. So let's use numbers this time around. Let's say we have matrix A. It has got numbers 2, 3, 4, and 5. And we are asked to find the determinant. How do we find the determinant? You just have to, first of all, multiply the major diagonal. This is called the major diagonal, the entries of the major diagonal. So you will say 2 times 5 minus, then the entries of the what? The the minor diagonal, the minor diagonal. So that is 4 times 3. So 2 times 10, 2 times 5 is 10, minus 4 times 3 is 12. So you get negative what? Negative 12 as your determinant. It is as simple as that. So find the entries of the major diagonal. And after finding the entries of the major diagonal, multiply the major diagonal entries, then minus the multiplication of the minor diagonal entries. Then we have learned how to find the determinant. But how do you find the inverse of a matrix now, like this one? Follow nicely. How do you find? So what you do, you say 1 over the determinant, you open the bracket. Then you switch these numbers in the major diagonal. They swap position. So 5 was down, it will be on top here. Then 2 was on top, it will be or down. First thing. You swap the entries of the major diagonal. Then these that are in the minor diagonal, they change signs. Observe that this was positive 3, it will now become negative 3. This one was positive 4, it will become negative what? 4. If 4 was negative, where negative 4, it could have become positive. So in short, it just changes the sign, right? How it changes the sign? You multiply both sides by negative 1. Okay. So now let's go ahead and find the inverse. This is the first step. So when you want to find the inverse of a matrix, how do you invert the matrix? Number 1, find the what? The determinant. Then you write 1 over the determinant. Our determinant is negative 12. So 1 over negative 12 times, we have already swapped these entries, 5 to negative 4 and the negative what? 3. Okay, that is what you do. Then from here, what are you going to do? What are you going to do? Okay, let's move on and see what we're going to do from here. Let me erase from here so that we can have enough space. What you're going to do from here is very simple. You're just going to start multiplying, okay, expanding all the entries by 1 over 12. So 1 over negative 12 times 5. And again, 1 over negative 12 times what? Negative 3. Again, 1 over 12 negative multiplied by what? Negative 4 here. And again, negative 1 over 12, which is the same thing as the negative, putting it down is still the same thing. Let me write it like this so that you're not confused, because you guys, you easily get confused. Negative 12 times what? 2. So in short, every number will be multiplied by what? By this scalar. We call this as a scalar. When you do that, obviously, you know that we can say 1 times 5, it will be 5 over negative 12. This one, 1 times negative 3, it will be negative 3 over negative 12. And here we have negative 1 times negative 4, it will be positive 4 over 12. And finally, here we have 1 times 2, it will give us 2 over negative 12. Then if you want, from here, you can still reduce this function, okay? You can reduce this these entries if you want. But if you don't want, you can still leave it here. But it doesn't look smart, yeah? When you leave it here, it will not look very smart. So you can reduce further. How do you reduce? You look for the number that can enter both sides on in this. So we have 5 and 12. We don't have any number that can enter in there. So it will remain as 5 over negative 12. Then 3 and the negative 3 and negative 12, there is a number that enters. 3 enters 3, 1. Again, 3 can enter into 12 4 times. Down here, we have 4 can enter into 4 1 time, and the 4 into 12 can enter 3 times. Here, 2 into 2 can enter 1, and the 2 into negative 12 can enter negative 6 times. And then when you reach here, you end. So this is your inverse. So it is very easy. Okay, very easy. So have you seen how we find the determinants, right? So basically, the first thing that you have to do is to find the determinant. After you have found the determinant now, say 1 over the determinant, then open the bracket and swap the entries in the major diagonal. Then those in the minor diagonal maintain their position, but they'll just change signs. And then from there, you multiply the matrices by the scale. 1 over determinant is called a scale. And that's how you find the inverse. So this is the inverse of the matrix. Let's go ahead now and pick an exam question from the Examination Council of Zambia. Let's pick an exam question. This is an exam question. Question number 4 is the one that we are looking at. It reads that given that the matrix N is equal to X to 2X6. Let's get the matrix first. Let's copy the matrix. Matrix is N is equal to X to X to 6 to 6. What is the question reading? So the question is saying that find the value of X for which the determinant of N is what? Is 8. So they are trying to tell you that, first of all, they have already solved for the determinant and they have found that the determinant is equal to what? Is equal to 8. So what do? You need to find the value of X. Very easy, don't panic. Then B is saying that, can you find the, hence or otherwise write N to the power negative 1. Now, N to the power negative 1, N, this matrix N to the power negative 1, is same as find the N inverse or the inverse of matrix N. I'll repeat that one. It is just as good as finding N inverse or the inverse of matrix what? Matrix N. So let's find. Let's go ahead and find the value of X. So they have already found the determinant, but for us to find the value of X, we'll have to assume as if there was no determinant and then equate to the determinant. So let's solve the way how we solve for the determinant. I said the entries of the major diagonal, okay, are multiplied, okay. So we'll have X multiplied by, 6, we close minus, then the entries of the what? These entries of the minor diagonal, right? So that will be 2x times 2, you close. This is how you find the determinant. All this is equal to 8. And so you shall say x times 6 giving you 6x minus 2x times 4 giving us 4x. All that is equal to what? Is equal to 8. So now, what is 6x minus 4x? It is giving us 2x, right? Equals to 8. So for x, we divide through by 2 everywhere so that x can be equal to what? To 4. So x is equal to what? 4. That's the value of x. So we have found the value of x. Very easy. So if you have found the value of x, it's very easy to renew to find the new n now. New matrix n is given us. Where there is x, we'll put 4. So it will be 4. We have put 4 here where there is x. 2. Then 6. Then 2 times 4. 2 times 4 here, it will be 8. You close. This is your new n. So new matrix n shall be 4, 2, 8, and 6. This is your new matrix n because you have found the value of x. So now that you have matrix n and you have the value of x, we are no longer concerned about the value of x now. We are just concerned about matrix n. And we have found the value of x that is still okay. So we'll mark the value of x only. That's what we are interested in. Then part B of the question is saying, can you find the inverse? So now we already have matrix n, right? We have said our matrix n is equal to what? Oh, matrix n is equal to to 4286, right? This is the matrix. 4268, and the determinant is 8. 4268. So n is equal to 4, 2, 8, and 6. Let me do this. Let me do this. Okay. Right. 4286. Yes, 4286. That is how it is done. 4286. 4286 as the new matrix. This is our matrix N. So we need to find the inverse of this, given that the determinant is what? 8. We said you say 1 over the determinant, and our determinant is 8. 1 over 8 times, what do we do to the numbers in the meta diagram? We swap them. 6, 4 go here. Then these in the minor diagonal, they change signs, -2 and -8, like that. Then from here, you can start multiplying the matrix by a scalar. Okay, what does it mean to multiply a matrix by a scalar? Simply means you say 1 over 8 times 6 -1. Okay, 1 over 8 again times -2 and -8 times 1 over 8 and the 1 over 8 times 4, like that. So when you say 1 times 6, it will give us 6 over 8. Then the next one will be 1 times -2, it will give us -2 over 8. And the negative 1 over 8 times the -8, it will give us -8 over 8. And 1 times 4 over 8, it will give us 4 over 8, like that. So from here, you can easily do what? Reduce the fraction, the matrix. Look for the numbers that can enter into these entries, into 6 and 8 without leaving a remainder. We can use 2. 2 into 6 goes 3 times, over 2 into 8 goes 4 times. 2 into -2 it goes -1 times, and 2 into 4 into 8 it goes 4 times. Here you can use 8. 8 into 8 is 1. And 8 into 8 can go there -1 time. And here 4 into 4 is 1. 4 into 8, 2, like that. You can leave here. You can leave your inverse. So basically, this is how you solve and define the determinant of the matrix. Very easy. Is there any question? Let us assume that you guys, since you're not asking, everything is fine with you. Okay, so we'll pick it up from here when we meet next time.